Lecture 1.2 will cover three topics. The first is Julia, which is our principal computational engine. It'll be used for scripting. And then we'll have a brief discussion of large language models, and in particular elements of the operation of a large language model that are relevant for being able to use it effectively throughout the class. And then finally, the last topic is validation, assuming that the AI assistant does the computational coding aspect of it. Our job is to be able to validate the results. So we'll be talking about different techniques that can be used for that. In the lecture at the top, and this will be true throughout the semester, there'll be listed any new Julia packages used, and it's not displayed automatically. So if you select it, it'll show that. For this particular lecture, there's a set of 3 packages that'll be installed to be able to run the programs in this class. So that's a nice way to reference for every particular lecture what are the new packages. And why that's important is that those are the ones you need to install into your system. By default, when you just start Julia, it doesn't have data frames, Cairo Mackie, or CSV installed. So those have to be explicitly installed. I think throughout the semester we have probably 12 to 15 total packages. So it's not going to be a large number. Later on, not this lecture, we'll be using the logjam package. That's the Julia package that was created specifically for logistics engineering. For this lecture, we're not using any of those. And then finally, starting with this lecture, the first lecture, there was no computational aspect to it, so that didn't have a script. But for this lecture and all the remaining ones, there'll be an associated Julia script. So it's a file with the name of the lecture, and then it has the ending .jl. And that indicates that it's a Julia script. For the class today, first in terms of Julia, in the lecture notes, I just give a brief overview of just the basic highlights of Julia. Again, we don't have to, in this class, be writing Julia code. You just have to understand it enough that if you are given Julia code, you can look at it and have a basic idea of what actually is happening. And I think we'll be using it enough that even though you're not actually writing the code, you should get pretty familiar in terms of what you're actually looking at. What we'll be using to run Julia code is VS Code, which you hopefully do have working at this point. So this is a little mock-up of what it actually looks like, but it's better if we actually go and look at VS Code directly. So this is VS Code. Again, hopefully you have this working. These are the different extensions. The ones that are really relevant for us, primarily you'll be using the Explorer, which you can see the files in different folders. So that'll be the primary extension. The only other one that is useful sometimes is the Julia extension. And for that, you can get a listing of different variables that you've defined in your workspace. So those are the 2 primary ones. And then also this shows you, these are all the installed extensions in your version of VS Code. When you first start, you'll have just a few of those, but over time, you'll typically have increasing numbers of extensions. You can see there's quite a lot. Essentially, these provide additional capabilities to the basic VS Code. But for our purposes, when you first start VS Code, you won't actually see this folder list here. So the first thing you want to do is, under Files, just open folder and then select where you have. In my case, I have my things in the document folder, and then under ISE 754. And then this is these are the same folders that you should have in your folder that have been pulled in from Git. So you should have a handouts and a materials and a work folder, along with these dot folders for Claude and for VS Code. These essentially have things like settings, etc. I'm going to go ahead and cancel that out since I already have. Notice here I have actually 2 different. Here's where I do development of the lectures and things for the class. And then here is the set here that actually duplicates what you should have. So just like you should, I've already had the Bootstrap output text showing the status of your installation. So that hopefully you've already uploaded and submitted to Moodle to show that you basically have your tool chain working. And then finally, the last is a Claude Markdown file. And this is sort of like uh, a file that Claude reads every time it runs in this folder. And it's a handy place to put special commands. If you wanted to do certain things, then it'll automatically, when it runs, execute what's, the commands that are in this. Notice the extension here, MD, that's for Markdown file. And if you've not seen them before, you'll be seeing a lot of Markdown files. It's basically the lingua franca of really large language models and AI in general. It's sort of a hybrid between just a straight text file and something more complex like HTML, used on web pages. That's more complicated than Markdown, but Markdown has more features than just basic text files. So it provides really a nice mix of the two, and it's perfectly readable. It doesn't have any obscure syntax. It essentially has almost no syntax. So it's a very robust, easy to use file format. So you'll be seeing that throughout the semester also. So to get started, one of the things I would like to do is look at the associated script with this lecture. So instead of going through the Julia material in the lecture, I just want to point out a few of the things in the script itself so you can get started working with it. So this has been put into the file. And you can ask Claude Code to, please, I want to start editing the script for lecture 1.2, and it should load into your folder this automatically. So you shouldn't really have to do this. You can let Claude Code do a lot of that work. So again, just clicking on it. To be able to see both, I can take this and then make it so that I have basically two columns. So here I have my script, and then here I have a bash command, and there are different scripts you can use. I tend to prefer bash, and bash I think is available if you install Git for Windows. If you're doing a Mac, then bash is, I think they have another name for it, but it's very similar. So that's a type of editor. Another is PowerShell. So there, again, different varieties of editors. For this class, though, we won't be doing a whole lot, in this bash editor. Most of the time, I would say the vast majority of the time, the only thing I use bash for is just when I click here, I just type Claude, and then it pops open, and now I'm actually in Claude Code itself. Here at the bottom gives information about what particular model that I'm operating in, and so on. You can at this point just kind of ignore, take whatever the defaults are, and then later, if necessary, you can focus on making changes. I think for what you need to do for quite a lot of the course, you can just accept defaults. There isn't a lot of necessarily types of customization that's required. I would like to focus a little bit more on this script here, but before doing that, I would like to relate it to, well, first let's look at the script here. In this script, this right here is a cell, and the lines here mean that you can basically execute everything in this cell with one command. And what this cell does is basically called get ready, class ready. It installs any packages that you need for that script. So if there's a particular package that you'll be using for the first time, this is a place where it'll actually be installed in your environment. So this is a cell that you can basically run it every time you start a script, and it'll do all the initialization to get you ready to go. So let me go ahead and do that. I can run it. One of the ways of doing that is if you press the Alt Enter key, and this is on Windows. When I do that, it'll start executing. And you can see a check mark here, and that check mark indicates that everything worked correctly. So the installation has happened and occurred the way it should occur. The next cell, it's basically a grouping of commands. These are a set of commands that actually appear in the lecture file itself. So I'm going to go back to the lecture file, and when we start talking about Julia in the lecture file, you'll see that that same set of code that appears in the script is actually in your lecture. So all of this, and you can copy it if you want, but it's already in the script, so you don't really need to do that. So in the lecture itself, it actually shows you have what actually executes. So this entire cell executes. And the way Julia works is this first command just runs, it assigns 2 to the variable t sub e. And notice that the subscript e is actually part of the name of the variable. That's one nice thing about Julia. You can define Greek letters, like this is sigma squared, meaning like referring to the variance. And 2, it doesn't mean physically actually squared. It's actually part of the name of the variable. And the way you do it would be /sigma. That gives you the sigma character. And then doing another backslash, and then the caret and 2, and then tab again. And that gives you the raised 2. So you can create, basically variable names that correspond quite closely to the way you would do it mathematically. And that's one of the reasons that Julia can look a lot closer to how you would see things mathematically as compared to Python. When you switch from Julia back to Python, one of the things that I really notice is I really kind of miss the descriptive variable names, and because Python does not have this capability. Last thing I'd like to point out is that in this, typically in a cell of Julia, only the result of the very last command is displayed. So here the result of this very last command is to output 3, and that's displayed here. If you want to see results in the lines before the last line in a cell, then you use the show command. It's @show. This is actually a macro, and what it does is it first displays what the equation is, but then it also importantly displays what this result is. So here you're able to see the intermediate results. Here you're defining the variable, so you don't need to do anything, but here you're actually calculating results, so you can see the intermediate result and then the. So if I want to be able to execute a single line of results, I can do Control Enter. If we do that, where are the results? Nothing is really showing up as output. What I want to do is be able to actually see the terminal. So under View, going here to the bottom, Terminal, you can see that what opens here at the bottom is a terminal, and this is called the Julia REPL. And that is basically where you can see the output of executing the results of the script. So here I did Control Enter. Notice that the cursor just stayed. If I want to actually advance the cursor, then instead of Control Enter, I can do Shift Enter. Then I get the same 2, but now I'm down to the next, which is the sigma. And then I can advance through one line at a time. Here I executed the show command. Here I got the 3. So these are the same outputs that were shown for the in the actual lecture itself. So these are all of the commands that appear in the Julia section. They're all just replaced here. Again, most of these you can follow as talked about in the lecture. One aspect of Julia that is different than most languages and can be a little bit annoying, especially when you first start with it, is the idea of dots. And it's talked about in the lecture, but I just want to quickly point out what that is. So I'm going to go here, and here I'm going to create an array A of the elements 1, 2, 3, 4. I'm going to do Shift Enter. So it displayed that 4-element vector. And then what's interesting is if I want to add 2 to all of them, I have to use the dot plus. And then if I do that, I get what I would expect, all the elements adding 2 to it. What if instead I'd forgotten to do the dot? If I just went 2 plus A, oops. Notice that I get an error, method error, no matching dot, so kind of a complicated way of saying that you probably wanted to actually do the dot plus. So don't, if you see an error like this, it's basically many times just you're actually missing the dot. Surprisingly, though, that the dot's required when you want to do things like this. The one case it's not required is if you want to multiply 2 times the elements of A. In that case, you can just do 2A. Notice there's no multiplication. So you could do, if you want, 2A, which you get the result, but you can just do 2A and you get the same result. Again, that's closer to the way you mathematically, if you 2 times a variable would be just 2 in the variable, not a multiplication. So again, it's a little bit closer to how things would be viewed mathematically. So these are all the elements in the script. This is an example of a function. Again, all of this appears in the lecture itself. So returning back to the lecture, you can, again, I would recommend just skimming through this in the lecture, and then as you start to use Julia more, you'll get familiar with it. But again, Claude Code is going to be your main engine to do the actual coding of it. So you just need to understand it well enough to understand if you ask it to create a script to illustrate how it actually solves something, that you can follow what it did. And if you're not comfortable with what it showed, then Claude is also a good place to ask it to explain, each line of what it did. So it's both a coder and a vehicle to actually explain what you're doing. And then the next topic is large language models. And for this class, there's not a whole lot of detail that you need, but I've included this section just as a reference primarily to give you an idea. I think the key thing is this epigraph right here. A language model does basically just one small thing. It predicts the next token. And the key is it just keeps doing that over and over again. And at least when I first read that, I said, yeah, it can't be true. I mean, even when they first came out in 2022, it just seemed like there has to be more going on than just predicting the next token. But surprisingly, that's essentially all it's doing, is predicting the next token based on essentially all of the knowledge in the world to create a model to use to do that prediction. And that's what makes it very effective. Here's an example. It is a stochastic process. So it's basically, if these are the existing set of words, or what tokens are essentially a portion of a word, it's a way of breaking complex words into smaller pieces. But primarily, large language models deal with tokens, which are, essentially very similar to what words are. So the best way to learn is, and then what's the next word going to be? The highest probability is by. It's to learn by doing. But there's also a non-zero probability that the best way to learn is through failure. So that's another option. So when you run a chat model in particular, you don't always get the same result, and that's what makes the results interesting. Here's a discussion of tokens and embeddings. Again, one of the things that makes a large language model effective is it doesn't just have a single variable representing each of these tokens. What it does is it actually represents each token by a 768 dimensional vector, essentially. That vector embeds the token into a 268 dimensional space. And as a result of that, after training with whatever data or whatever text it's learning, over time it learns that the word freight tends to be physically close in that high dimensional space to shipments, to trucks, for example, but it's actually pretty far away from cats. It's not close to cat space. So that's the aspect of embeddings that really makes it useful. It basically uses proximity to get a good idea of what terms are related to each other. And again, that's what makes it very effective for understanding language. There's some discussion of neural nets, and there's also some, if you're interested, there's some drop downs with more details. Whenever in a lecture you see a blue drop down like this, what it's saying is that none of this material is going to be on any homework or exam. It's just there if you're interested, if you find it, curious, or find that it provides a more interesting explanation of something. But it's all sort of peripheral to the main body of what we'll be covering in the class. This one figure I just want to point out, it kind of explains what, when you're using Claude Code for this class and for other applications, essentially what you're doing is you're managing the context window. The context window is basically all of the information in the model that was not part of its initial training. So it would correspond to all of the elements that are in the memory of the model. And nowadays, models have like 1 million tokens in context. So everything you put into it, all of your previous prompts, all of that gets added to that context. So what's in your context materially impacts the result of what you get out of the model. So doing good prompts, for example, it works because what's in context is very effective in steering the output to things you're interested in. Whereas when you have things in context, say you're solving a problem and then halfway through switch to doing another problem, well, you're going to be using a lot of your limited context availability that stores things not related to what your problem is. And all it does is it serves to degrade the performance of it. So in that case, it's probably good to clear the context, and there are commands to do that, or just start a new session. So once you start using Claude Code, if you've not used it before, as you start to use it, you start to get a basic intuitive feeling for when results are starting to not be as good as they were before. Quite often that's the case, that you're getting context rot, they call it, where you're getting things in context that are probably not really helping it. So again, this is something that we'll be talking about throughout the semester in terms of what are the elements that can make the results of the large language models effective. And then the very last topic that I want to cover, again, just briefly, is the topic of validation. And validation is something that, it's not anything new for using a large language model, but at least in my experience, at least for teaching, rarely did I was, struggling enough just to get the basic concepts across. And since logistics engineering is very computationally focused, just getting all the mechanics of the syntax correct, to be able to have students in class be able to actually create a computational script that solved the real logistics engineering problem was really quite a struggle. It took quite a lot of effort. So there really was just never time to then, once you had that result, to actually do things like a proper validation. And one of the nice things of the AI assistant like Claude Code is it's really freed up the time to be able to do exactly that type of thing. So now, since the middle part of actually creating the result is much simpler and quicker, now we can do a more proper validation. And the nice thing is that the AI assistant itself can help with the validation if it's used in the proper way. So to be concrete about it, there are a set of 9 different types of validation checks that I tend to use, and I classified them in 3 different categories. The first are the really simple ones that can be used almost all the time. Are the units correct? Does the result, violate any natural bound, for example? If you have a result that always has to be a non-negative result, and if you get a negative result, then, that you probably should be concerned that something's not quite right about your answer. So screens are pretty simple types of validation. And then expectations, you have to more purposefully actually come up with scenarios that actually test the validation. And then finally, confirmations are when you're doing something really important. So if you're doing research that's going to appear in your dissertation and into a journal paper, if you're doing work for an actual client, or you're at your job and you're creating a project at work and it needs to be done correctly, your name's behind it, then what are the different things that you can do when you get a result from Claude Code where you think it's right, but how do you actually convince yourself before you can convince anybody else that it really is a correct result? And these are different types of validation. And in the lecture, I've gone through and actually taken the examples that we had covered in the first lecture, 1.1, the discussing modeling, and I've showed either how some of the validation was done in the examples from the lecture, and in cases where it was not done, I've shown how the different types of validation could be used for these particular problems. So here's a repeat of the 4 different examples that were in that first lecture, and I've listed what different types of validation were used or not used and then are used here for the first time to actually do the validation. So this is all a discussion of to give you actually a concrete example of how that type of validation could be used in a problem like this. The other thing, so in addition to those 9 different types of validation, the one other thing that I do, I don't do it all the time, but whenever it's something that's really important, I always ask for the script. I don't accept, and it's different if I'm in Claude Code, if I want to be able to process a file and I want to make sure that it always eliminates some whatever element, that I don't really care to examine exactly how it did that. And the reason is that I can look at the output of what it produced. If I wanted to, capitalize the first name of, whatever, and I can mechanically basically do that. So it's easy for me to validate. I don't really care about what the details of the script. And for large language models like Claude Code, whenever you ask it to do something and don't explicitly say, create a Julia script, by default, it'll create a Python script. So when you're using Claude Code, internally to do a lot of other things, quite often Python will be what it chooses to use. But for this class, we're not using Python at all. We're going to be basically requiring everything to be Julia. And the reason is that all of the assignments for this class are things that you do need to understand and be able to validate. So Python would not be appropriate because we're not covering Python for the class. So for the things that you create, you'll want to have a script written in Julia, and that's what you'll first be able to look through it and validate how it actually solved the problem. This is an example here where, say you were given a comma-separated file with these different elements representing different shipments, the origin, destination, and size of the shipments in tons, and you wanted the median value. Well, this would be a great thing for Claude Code. You could literally just, take this and paste it into Claude Code, ask it to calculate the median. And if you look at what it does, and as it's operating, you can see it scrolling, and you'll see it actually is using the awk language, which is a language that actually is convenient for doing these type of things. And large language models are trained on these type of cryptic scripting languages. But most people are not really familiar with, this has been around since the 1970s, this awk language. So there's lots of data available. So when they were training models like Claude, there was a lot of examples of using this language. So Claude is really good at doing this. The problem is I'm not good at doing this. I can look at it and, I can, if I run it, I can see it gave the median, but can I be sure that it did it? Median is something that's easy to check. What if it was a more complicated statistical test that, it's not obvious what the answer is? I'd want to be able to check to see, is it really calculating it the way I think it should be calculated? Well, so instead of doing this, you can ask for the same result, and here request saying deliver this using a Julia script. And here is a Julia script that does exactly the same thing. Here it's using the two packages, one to read the CSV file, and then it's using the data frames package to read that structured data. And here is more of the way I would think how to calculate the median. You basically handle either the odd or even numbers of rows, and then just calculate and report out the results. So this is something I can look at, and even if you're just starting with Julia, it's, I think, pretty self-explanatory, most of what's happening here. And the few things that you're not familiar with, you can always just copy some of this code, put it into Claude Code, ask to explain what exactly does this mean. You can also, when it does a script, you can always request that it puts comments to the side to help you understand what it's doing. So this is a much better vehicle for you being able to have some confidence in whatever your AI is doing is actually a valid calculation. And the nice thing is that if things change or you want to really validate it, you can try changing some of the numbers and see what happens, and you can track the whole process. The last thing I want to talk about before wrapping up today is one of the things that we're going to ask you to do. And say it's a problem, say you want to find the best location for a warehouse. We'll be talking about some of those type of models later when we get the location. I think in the first lecture, there was an example of a strategic modeling problem to find the location for 6 hubs. And we didn't talk about how actually to find that. Well, this is using that same model format that we introduced before. So instead of giving Claude Code just the command find the best location for the warehouse, that's really, it doesn't have any kind of real context of what exactly. Well, by using this format, this provides in much more detail what exactly is the problem that we're looking at. And the nice thing about doing this is we can save this as a markdown file, just like the Claude.md. You can create your own model.md file, put this model format into there, and then when you're in Claude Code, you can just say read the model file and then write a Julia script and implement it and run it. So it's an easy way to be able to run this markdown. But the nice thing is that if you had just done all of this within the prompt in Claude Code, as soon as you exit Claude Code, all of this would be gone. So the advantage of doing this as a separate markdown file is that it's still there in your folder even when you exit out of Claude Code. And then later on, if you realize that it's missing something and needs to be changed, you have a markdown file that can be edited in VS Code. So it provides a very nice vehicle to be able to effectively be able to modify things that are then put into Claude Code for execution. So the last thing is I'd like to then let's go back to VS Code. And what I'm going to do is I want to copy all of this. So before we do that, let me go up here and I'm going to click copy so it's in the clipboard. Then if I go back to my VS Code, I'm going to lower this a little bit. Basically what I want to do is create another file called model.md, and I can do that by if I go under file and then create new file. I can give it the name. I'm going to call it model and then .md, hit return, put it in the same folder here. So I'm going to create the file and then there it is. Then it's very conveniently pasted it right or opened it right here in this right hand column in VS Code. And then all I need to do is go into this and then I'm just going to paste the code here. So this was what was from the clipboard, and then I can save, do Control S to save this result. And now I have this as a markdown file. And then if I want to, I can then go ahead and copy the command. I think it was read the file. So read And then notice that I'm actually just I'm not actually in the lectures folder. I'm running this from the ISE 754. So sometimes the file can be quite deep in subfolders. So there's one nice feature of Claude Code. If I did just read and then just gave the model name, model.md, it would probably find it, but it might take a while. If you want to make sure that you're referring to a particular file, you can use the @ command, and then it suggests different files that are available. And then as you type, M didn't find it, but then if I do MO, what's up at the top here is what his guess is, and that is the file. So it's in the work folder, and the lecture subfolder, and then it's model.md. So I could just select that. And I'm not going to do that particular prompt. I'm just going to then report any problems. So is there, what happened? Are there any problems with that particular markdown file? And now Claude Code is actually executing it. I think there's about 150 different little things here as it's solving it, just to keep you from getting bored. It'll change out different things it's considering, and then it might switch to something else as it's actually executing. Notice I kept it pretty open. I didn't say what particular types of problems. So Claude Code is going to have to guess what I meant by problems. It could be problems with the model, problems with the syntax. So this is an example of probably not a really great prompt. It would probably do much better if I could have been much more specific about what type of problem that I was focusing on. And because of that uncertainty, it's taking it much longer. It's probably trying out different, trying to interpret exactly what are the different types of problems. And since it wasn't specified, it'll probably try to report back all kinds of different problems. And then I'll have to select from that. So if you don't prompt well, you pay the price in having to wait longer to get the results. And then when you do get results, you'll probably get results that are much more detailed than you really want them to be, and then you'll have to spend time actually then focusing on what you're actually interested in. So it's thinking some more. Simple question, like any problems, look how long it's taking it. Part of it, again, it's because it's so open-ended. It's probably thinking of things that I didn't even consider as a possible problem with the way it's been formulated. All right, this is its result. So it did quite a lot of work. Basically, first it says the format check passes. In the materials invite, there's actually a Julia script called check model. So every time you run it in Claude Code, it'll actually execute this script here. It's in the environment, and it's called check model. So it's doing the work to make sure that you're using the correct keywords, just so that doesn't cause any problems. So this is a script that we created to make it less likely you have just simple formatting issues. So the format checks out. Here, there's no assumption of what type of distance is being referred to. Straight line, great circle distances. Again, when we get to location types of problems, we'll be talking about these kind of things in more detail. There's no cost proportionality assumption. Weekly demand is the physical weight, not a monetary. So it's giving all these possible problems, what exactly we were referring to. So with this, really, I wouldn't know what to really do with it. There's so many things on the table here. And again, it's just because the prompt itself, so basically and what's nice thing is it actually suggests what a fix is. Here is fix the missing assumptions in the model. And if you want to accept it, if you hit the tab when you're in here, then you can just hit return and it'll go ahead and fix those assumptions. So again, we'll go ahead and stop at this point, but hopefully this is enough to get you started with Julia Claude Code, and using both together to actually solve logistics engineering problems.